Dear students, in this lecture we are going to study the heterocyclic compound, that is thiophene, the topic from the second year B Pharmacy semester 4, subject Pharmaceutical Organic Chemistry 3. You can see the structure for the thiophene. It is the 5-membered ring with sulfur at a first position. It is present in a coal tar along with a benzene and a shale oil. Thiophene, it is the closeness of its boiling point near about 84 degrees Celsius with that of benzene that having the 80 degrees Celsius, and so both cannot be separated by distillation. Hence thiophene is always present as an impurity in commercial benzene. Thiophene is a 5-membered ring containing sulfur as the heteroatom. The structure of thiophene is quite similar to pyrrole and furan. The physical properties of thiophene, the color of thiophene, it is a colorless. Solubility, it is soluble in water. Then boiling point is 84 degrees Celsius. The stabilization energy of thiophene is 11 kilocalorie per mole. Now we will see in detail the different synthesis method of thiophene. The first one is Pal-Knorr synthesis. Thiophene derivatives may be prepared by heating 2,4-dicarbonyl compound with a phosphorus pentasulfide. Now this is your 2,4-dicarbonyl compound. You can see the nomenclature 1, 2, 3 and 4. Now this is the first carbonyl group and this is second, that's why it is a instead of 2,4 it is a 1,4-dicarbonyl compound, which is when heated with the phosphorus pentasulfide it will give 2,5-dimethyl thiophene, or you can say it is a thiophene derivative. The second method for the synthesis of thiophene is from the acetylene and H2S, or the thiophene is prepared from the acetylene and hydrogen disulfide pass over the alumina at a 400 degrees Celsius. You can see the structure of acetylene. When two molecules of acetylene treated with a H2S gas, and this mixture when pass over the alumina at a higher temperature near about 400 degrees Celsius, it will give a thiophene. The third method for the preparation of thiophene is from sulfur and N-butane. It is a commercial method. By the direct reaction between sulfur and the N-butane in a vapor phase at 65 degrees Celsius produce a thiophene molecule. See, you can see in this reaction when N-butane molecule is heated with a sulfur molecule at near about 65 degrees Celsius, it will produce thiophene along with hydrogen sulfide gas. Next method is by distillation of fluoric acid and barium sulfide. You can see when fluoric acid is treated with barium sulfide, it will produce a thiophene along with a barium carbonate. Next method by distillation of sodium succinate with a P2S5. When sodium succinate is treated with P2S5, it will give a thiophene along with the hydrogen sulfide gas. Now we can summarize the different synthesis method for the thiophene. That is, first is Pal-Knorr synthesis, second is from acetylene and H2S. Next is from sulfur and N-butane, then by distillation of fluoric acid and barium sulfide, and lastly by distillation of sodium succinate with the P2S5. Now we will see in detail the different chemical reactions of thiophene. First is acetylation. So when thiophene is treated with the acetyl chloride along with the tin chloride, then it will produce 2-acetyl thiophene. Second one reaction is chloromethylation. In this reaction, when thiophene is treated with a formaldehyde along with HCl, it will give 2-chloromethyl thiophene. The next reaction is a halogenation reaction. When thiophene is treated with bromine, it will produce 2,5-dibromothiophene. Then next is nitration. Thiophene is treated with nitric acid and acetic acid, then it will produce 2-nitrothiophene. Dear student, please remember the nitration reaction of all heterocyclic compound is generally carried out in presence of nitric acid and acetic acid. Instead of using the usual nitrating mixture H2SO4, there is the use of acetic acid, because when nitrating mixture is used, it will decompose your thiophene or any other heterocyclic compound. So nitration of thiophene is always carried out in presence of nitric acid and acetic acid to give 2-nitrothiophene. The next reaction is sulfonation of thiophene. Sulfonation of thiophene is carried out in presence of H2SO4 to give thiophene 2-sulfonic acid. The next reaction is reaction with N-alkyl lithium. When N-butyl lithium forms 2-lithium derivative with a thiophene. When thiophene is treated with butyl lithium, then it will form a 2-lithium derivative. When this molecule is further treated with carbon dioxide or alkyl halide, then at the second position of thiophene, acidic functional group or the alkyl functional group gets substituted. The next reaction is the reduction reaction. Reduction of thiophene with sodium in liquid ammonia gives a mixture of 2,3-dihydro and 2,5-dihydrothiophene. You can see in a reaction, this thiophene molecule is treated with sodium and liquid ammonia, then it will get substituted, it will carried out the reduction at the 2 and 3 position. That's why it is the 2,3-dihydrothiophene along with the 2,5-dihydrothiophene. The catalytic reduction with the Raney nickel removes the sulfur atom and thus forms N-butane. Now this thiophene when the reduction of this thiophene is carried out in presence of Raney nickel, then it will produce N-butane molecule. Now we will summarize the chemical reaction for thiophene. First one is acetylation, second one is chloromethylation, third one is halogenation, then fourth one is nitration, fifth one is sulfonation, sixth one is reaction with N-alkyl lithium, seventh one is reduction reaction, which is carried out generally in presence of sodium and liquid ammonia and Raney nickel. Now we will see in which drug molecule this thiophene structure is basically present. For example, in antihistaminic drugs like methapylaline, some non-steroidal anti-infectory drugs, that is suprofen, antibiotics like ticarcillin, cephalothin, some anti-neoplastic drug, some antidepressant, and some anti-asthmatic drugs like xyloviton. These drugs are there. These compounds are there in which the thiophene molecule is present. Thank you and happy learning.